Introduction. The reason we learn mathematical logic is basically a line of reasoning that mathematicians would apply in order to convince someone about the truth of a mathematical statement. A proposal could be rephrased, proved differently, refined, completed, and etc. All the above play a crucial role in the mathematical progress. In this subject, we have learned various topics such as set theory, logic, and proving techniques. For this group project, we focus one topic under logic, which is logical equivalence. So what is logic equivalence? So logic equivalence when two statements A and B are said to be logical equivalent and we rewrite as A by conditional B. Consider logical equivalent if they have the same truth value. The last column of the table must be identical. There are three types of logical equivalence, which are tautology, contradiction, and contingency. So what's mean of tautology? So tautology is when the last column consists of true only. We can see in the example below. Second one is contradiction, when the last column consists of false only. So you can see in the statement below. While contingency is when some of the statement either true or false. So next one is conditional proposition. So basically conditional proposition have three types of the symbolic form of a statement. So in this case, we use a statement of if P then Q. So in the symbolic form of the basic one is conditional is P implies Q, while the converse one it become Q implies P, and inverse become not P implies not Q, while contrapositive it become not Q implies not P. The next one is only if statement. There's three types of only if statement, which is the first one is A if and only if B. It's also logic equivalent to A if B and A only if B. The next one is A if B statement. So A if B statements means if B then A, denoted with B implies A. And another one is A only if B statement means if A then B. Logic equivalent if not B, then not A.
For question 1, state whether P and Q in bracket or not P or P and not Q in bracket, in square bracket or P or not R in bracket is a tautology, contradiction or neither. Construct a truth table to determine its truth values. First, we need P, Q and R to complete the whole table. Then, we need not P, not Q, and not R. To get this truth value, we just need to list down the opposite of the original value. After that, we need to find the truth value for all the statements that we need to solve the statement required by the question. The answer that we get for P and Q in bracket are not P or P and not Q in square bracket or Q or not R in bracket is all true. The conclusion that we get for this truth table is, since the truth value contains all true, then the truth value for this statement is tautology.
Question 2. Given the following statement, Aina is saying, if nasi kerabu is expensive, then it must taste good. Auni is saying, if nasi kerabu tastes good, then it must be expensive. Are they logically saying the same thing? Give reason to support your answer. So, firstly, you must know the P and Q at these two statements. P is nasi kerabu is expensive, while Q is nasi kerabu tastes good. For statement 1, that Aina is saying if nasi kerabu is expensive, then it must taste good. The symbolic form is P implies Q. For statement 2, that Auni is saying if nasi kerabu tastes good, then it must be expensive. The symbolic form is Q implies P. So, for the answer, you must find P implies Q equivalent to Q implies P. Firstly, you must do the truth table. At this truth table, you must find P implies Q and Q implies P, and lastly is P implies Q equivalent to Q implies P. For the answer, true, true, false, 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 true, true. Therefore, they're logically not saying the same thing. It is because since the truth value of P implies Q is not identical to the truth value of Q implies P.
Question 3. Write in sentence the appropriate conditional proposition for each of the following conditional statement. So the first is I will drive to work if it rains today. Symbolic form is Q implies P. So write in sentence the converse of its inverse. The first thing first, we need to find the inverse from Q implies P. So we will get not Q implies not P. And from not Q implies not P, we need to find the converse. So the last, we will get not P implies not Q. Next, if it's rain today, then I will drive to work. The symbolic form is P implies Q. So we need to write in sentence the inverse of its converse. The first thing first, we need to, same like before, we need to find the converse from P implies Q. So the answer is Q implies P. So from Q implies P, we need to find the inverse. So we will get not Q implies not P. So from this symbolic form, we need to change into the sentence, and the answer is if I will not drive to work, then it's not rain today.
Okay, question 4 asks us to write the statement in word. So there are 3 statements that we have to answer. First is negation of statement 1, second is converse of statement 2, and last is inverse of statement 3. So let's do together. First of all, we take out the variables P and Q from the statement so that we can write a symbolic form easily. The symbolic form of this statement is P and Q. Now we will negate this statement. Firstly, we put negation sign in front of this statement. Then we use De Moivre's law to bring the negation sign inside. After that, we get our answer, which is not P or not Q. Then we can write this statement in words like I already stated on the screen. Next is for converse of statement 2. Same as before, we take out variables P and Q first. And we can see this statement is if-then statement. So we can conclude that the symbolic form of this statement is P implies Q. And then we can proceed to converse this statement. So how to settle it? Okay, in introduction just now, they already have explanation on how to change the conditional proposition. So we only follow it. Now we already have a symbolic form for converse, which is Q implies P. With this, we can write this statement in word, which is we only write it with if Q then P using the same variables. Lastly is inverse of statement 3. So after we take out the variables, we have to alert that this statement is if statement. There are different between if statement and if-then statement. The symbolic form of this statement is Q implies P. Different, right, compared than if-then statement. Okay, without wasting time, now we have to inverse this statement. This also like statement 2, we only have to follow the law they are already given. So the symbolic form is not Q implies not P. And now we can write this in word. But remember guys, if the question already give us if statement, we should write our answer same as question. Don't forget guys.
Conclusion. To summarize, we need to understand the meaning of logical equivalence, identify the difference between tautology, condition, and contingency in order to make a conclusion based on the truth table. Besides that, we need to know the symbolic form of conditional proposition, which is inverse, converse, and contrapositive, so we can answer the question. Lastly, this topic will become easy as long as you can comprehend the term that has been asked from the question. The key to score this topic is try to do a lot of exercise so that we can fully grasp the concept of this topic.